Okay, so my name is Igor Šćekić. As you can see, my last name has many of these ticks above it. So if someone is not from the Balkans and would like to try to pronounce it, you can catch me afterwards. I love hearing people mispronounce my last name. People really like to talk about themselves, and I am really not an exception. So uh, to begin with, I'm a software developer and a technical team leader at Execom. I lead about 20 people. Execom is a outsourcing company based here in Novi Sad. We have many different clients from all across the world. Okay. Okay. Uh, so as I was saying, we have many different clients from all across the world. We have many different domains as well. The domain that I'm working in is the financial and insurance sector. So I have a very strict NDA, and if any of you work in that domain, you probably have one as well, so you know what I'm talking about. And I cannot tell you anything about my project except the technologies that I work with. So I'm a full stack developer, and I do the backend part of the stack in either Node.js or Java. Specifically on that project, I'm working with Java. And we're not going to talk about Java a lot since this is a front-end JavaScript conference. For the front end, we use the latest React and Redux. And actually, my colleagues, which work with me on this project, have been the ones who have made me apply and actually try, who have gotten me to do this talk, because I've had some performance issues in our very large application. And I was so happy when I saw them, and they were like, yeah, there's this conference here in Novi Sad. I mean, we were supposed to go. I was supposed to be just a listener, but then they said, you should totally do a talk about this. And I was like, okay, I'll apply. So I would like to thank the organizers for letting me have a chance to do this, and also thank them for giving me the last slot. I know this might seem weird, but you know, I would like to joke and say that, you know, they left the best for last. Although that wouldn't be fair to my fellow speakers. We've actually had some amazing talks over the last 2 days, so I'm not going to insult them like that. Anyway, since this is a React and Redux presentation, I assumed that most of you have worked with these. So by a show of hands, could we please see how many of you work with React on a daily basis? Well, I'd say around 70% of the room. And how about Redux? Okay, still the same 70%. Anyone using something other than Redux? For example, MobX? Okay, one hand above there. So not a lot of people not using Redux. Okay, and yeah, I would like to set some expectations for this presentation, and that is that this is meant for people with, let's say, medium experience with React and Redux. Juniors from my point of view always struggle with actually getting the features done, while seniors know most of this stuff. Maybe you'll see something new if you're like a senior. So yeah, let's get going. This was longer than I expected. For those of you who have not worked with React, we're going to take a step back to like a history lesson and see how React came to be the most popular framework, or rather the most popular view library that exists today. And we are going to go back around 3 years, and I don't know if any of you remember. No, okay. Is this thing on? Okay. Okay, so we're going back around 3-4 years, I guess. These were my programming like beginnings. I was a baby programmer. I was learning JavaScript all by my own. And at that time, there was something called JS fatigue, which, to understand this, you would have really had to have lived through it. But in like everyday words, we had a bunch of libraries coming out every week, every other week. There was no clear winner in the framework wars, as I like to call them. So we didn't know what we were going to use in the future. And as a baby developer back then, I stumbled upon React. I really liked it, and I gambled that this was going to be the new big thing, and apparently I got lucky, so I can say that today I was right, but I couldn't be sure at the time. While all of this is happening, all of this new tooling was coming out, all of these new frameworks, new libraries, new principles. For example, the Flux principle was a big thing back then, before even Redux existed, I believe. All the while, backend developers were ranting on Twitter how this is all madness. How can you live in this world where nothing is stable, and you don't know what you're going to do next week, and all this knowledge that you're now acquiring is non-transferable. And some of them still like to joke that way, but I always tell them for the last 3 years I've been working with the same language and the same view library or framework, and most of them haven't, so that usually shuts them up. But yeah, anyway, they were on the sidelines with their arms crossed like this, and they were like, nope, don't want any part of that. And yeah, eventually React emerged as the winner. Obviously, this was for multiple reasons. It's very small, very concise. At the time, it introduced JSX, which was a new thing. Not many people disliked it. I like to put it that way. I liked it personally. And I guess I think the second biggest, at least for me, the second biggest reason why it won was its backing by Facebook. Facebook has a really, as far as I know, a really good open source track record, and they support their stuff. For example, Cassandra, which some of you may have used, it has originally been made in Facebook. Also, the hip hop virtual machine for PHP. They have plenty of other stuff as well. So yeah, that was, I think, the second most important reason. But at least for me, one of the most important reason was speed. I had this old laptop back then when I was learning, and you cannot believe how slow that laptop was. It was insanely slow. Like, we're talking 2 gigabytes of RAM, 1 processor core, terrible. And I was trying to become a web developer, a front-end developer on such a slow machine. So when I tried React, it was fast, even on my machine. So I knew that this was a thing which was going to be even faster, like on a regular normal laptop or a desktop. Yeah, also at the time, other frameworks which were big, for example, AngularJS. Has anyone worked with AngularJS? Yeah. Of those who have raised their hands, leave your hand up if you like it. Yeah, not many hands have been left up. I think around 5. I really dislike it personally. I think it's slow. Main reason, right? So yeah, React was fast, and back then I think it was, I guess, socially acceptable for your web application to not be 60 FPS or to be performant. Everyone was like, oh yeah, this web application is kind of stuttering, but it's to be expected. It's the web, it's the browsers. These JavaScript guys, they can't make fast stuff. And that has changed. Like, modern web applications are expected to be silky smooth, and they're expected to, we always mention this 60 FPS, which we all want to have in our web application. And does anyone actually know why 60? Where did that number come from? Anyone know? Just raise your hand if you know. You don't need to answer. Okay, so the number 60 is because of the refresh rate of the modern monitors which we have today, which is 60 Hertz. So a modern monitor can only display 60 FPS due to its refresh rate. So if you are feeding the monitor more frames from your graphics card, it's simply not going to show them because it's not physically able to. So yeah, that's where the 60 comes from. And we also want the 60 on, for example, mobile devices or devices which are, let's say, computationally less powerful than our, big i7 16 gigabytes of RAM laptops. And yeah, are there any gamers out here in the room? Are your monitors more than 100 Hertz? Okay, so if they're not, buy one. It's amazing. But yeah, these modern gaming monitors are all very high frequency, which means they can display more than these 60 FPS. They can display, for example, 144 or 200, I think 40, I'm not sure. Anyway, they can display more than 60, and this means that we have even less time between frames to do our own stuff for us to catch up with the monitor. So the monitor is a lot faster than these 60. We often say that we have 16 milliseconds, 16.6 to achieve between frames to achieve 60 FPS. For high frequency monitors, that time has been cut by more than half. And to top it off, this 16 milliseconds isn't all for our code. Actually, most of it is not for our code. Our code is generally very fast, and then we have the framework code, and then we also have the browser and yeah, the browser doing its own thing. Like on the last talk that was mentioned, there was some styling going on, layouts, painting, all. I'm not really like technically. How should I put this? I don't really know exactly all the steps the browser takes, but it takes a significant amount of that 16 milliseconds. So what we can influence is basically minimizing the amount of time both the framework and the browser need to do to actually display that frame, and that's what we want to achieve by optimizing performance. So yeah, this is like a philosophical slide, I guess, and it is regarding performance optimizations in general, which is we always want to achieve the correct result in the least amount of work required, in the least amount of work possible. And sometimes that least amount of work is still a significant amount of work which we cannot avoid by any means. So we need to be smart about how we optimize and when we optimize. And for example, this is most obvious when dealing with stuff like, I'd say, lazy loading or preloading, where if you've been to the talk about video delivery, I think it was yesterday, the speaker, I forgot his name, I'm so sorry. The speaker said that there was a website which preloaded an entire video which was at the bottom of the page. So this is a waste. This was not a smart optimization. That video is never visible, and we have just wasted precious CPU cycles. So yeah, with performance optimizations, we need to be aware of the amount of work that we do. We need to minimize it, and then we also want to be smart about them when we cannot avoid a significant amount of work. And yeah, as the sentence says, your application is fastest when nothing is happening. I mean, have you ever tried loading an empty HTML file in your browser? It's instant, right? So try to make nothing happen as often as possible. That's like the mantra of optimization in the browser, at least for me. That's what I try to do. Okay, then we're going to switch to React. And for those of you who are not, let's say, who do not work daily with React or who have not had the chance to try it, this part might be a little bit too deep. I'm sorry about that, but the title of the talk was React and Redux, so I can't waste too much time explaining. The important thing to know is that a re-render is something React does when you want to update the view. And well, there are certain triggers for React for when it actually does the update, when it actually does your render, and then in this render diff patch cycle, when React does a render, it actually constructs a virtual DOM tree, compares that virtual DOM tree with the previous virtual DOM tree, creates a diff from that, and then uses that diff to patch the actual DOM. And that's like a very high-level overview of how the React lifecycle works. And these, in this lifecycle, there are certain things that we can and cannot influence. Obviously, we cannot influence the patching of the DOM. That's up to the React developers to optimize. But what we can do is help React out in the render and the diff parts of the lifecycle. And we do that by actually telling React, okay, this part of the DOM tree, you do not need to diff. I am personally guaranteeing that this is the same as it was before. And that's something we're going to talk about a little bit more later, but let's get back to triggers for renders. So React has this thing called state, and I assume that the crowd who has worked with React has actually set state at some point. So an interview question that I really like to ask, I think I ask it every time when a React developer comes to Execom, is set state a synchronous or an asynchronous operation? So you can think about it, and if you thought it was asynchronous, you were correct. So setting state actually doesn't set it immediately. It just tells React, hey, I need this update, and you do your own thing and do it when you are able to. So the reason for this is because JavaScript is single-threaded, and then if we had multiple components all updating their state at the same time, we would block the UI thread, and that would lead to UI jank and freezes and stuff, which is obviously bad. So yeah, that's one of the render triggers. By the way, it's possible that these are not the only ones, but these are the ones that I find interesting to talk about. So if there are other ones, please let me know. Yeah, there's another one, and it's like dashed. It's dashed because the text is strike through, because I heavily discourage using this, and also I have never seen it used in production. And it's this force update method. Has anyone ever used it? actually. Okay, good. Put your hand down. So force update actually forces, like its name says, forces your component to re-render, even though nothing might have happened. And you could use force update to do something like, I don't know, mutate some props directly instead of, using React patterns which are well established. And then by doing that, you force update and you have triggered the render by force. A medium amusement fact, I wouldn't say it's a fun fact, but a medium amusement fact about force update is that it skips the should component update lifecycle hook. So if you call this, you have essentially said, yeah, render no matter what, I don't care what should component update is saying. And yeah, when I ask this question on interviews, like when does React re-render, or what triggers a re-render in React, most junior developers say, oh yeah, when state changes, okay, correct, or when props change. And that's the reason for this last sentence here. Props actually cannot ever cause a render. They are passed to a component, and then the result of a render can be different because the props have changed, but changing props cannot actually trigger a render itself. I mean, obviously there are some edge cases, like for example, if that prop is, I don't know, a value of a context provider or something. But in general, props themselves cannot trigger a state update. The props themselves change because of a state update higher up in the tree. Like some parent state has changed, and then that has propagated down to this component, to its props, and then because of that, we get a different result from a render. Okay, so more about props. Most components, I mean, I strive to make most of my components dumb. If you have read some documentation or tutorials about React and Redux, you've probably seen that they differentiate between smart components, which contain business logic, which are connected to the store usually, and dumb components, which are, for example, a button, and it takes a function as a prop, and then when you click on it, it just calls its prop. So it's like a dumb component, and it only depends on its props, and usually these components are functional components as well. So we are going to talk about preventing a re-render in a component preventing a different render result in a component which only is dependent on its props. And this is where should component update comes in. So has anyone used should component update before? And if you have successfully used it, like written the code and then it worked for the first time, leave your hand up. So it's tricky to use because you need to make sure that your previous props and your previous state are that you're taking care of whether you actually need to do an update or not, and then usually you forget something like, yeah, I need to update when the state updates, but also when this prop is updated, but then again I want to ignore this other prop. And there's always the issue of having whether should component update should follow like a blacklist or a whitelist. So I want to update only if these items change, or I don't want to update if this item changes. So it's often tricky to make it right because a component can have a large amount of props or a small amount of props, and generally you do not want to have a custom should component update. And there's also the common pitfall of having the check in should component update actually more expensive than rendering the component. I've seen this like doing crazy deep equals checks in should component update, which are more expensive and take more time than actually rendering the result. Pure component is listed here. Has anyone used pure component? Okay. Well, pure component is nothing special. It just implements a should component update for you, which does a shallow equals check. A shallow equals check basically means that it checks all of the props by reference, and shallow means that it's not going deep. So for example, if you have an object tree, it will only check the first parent object. It will not check its children. So if you have changes in the children, your pure component might not re-render, and you need to be careful when using it. And I skipped this part about primitive versus non-primitive types. And this is important because pure component, as I said, as it implements a shallow comparison, the shallow comparison just compares like you can imagine it like just a triple equals between old props and new prop, or rather old prop and new prop. This check is, I guess, intuitive for primitive types, for example, numbers or strings, where you can have 1 equals 1, that's true. But if you have objects or arrays or functions or any other non-primitive type, then you must take care to actually have the same reference, otherwise pure component will fail, because it will fail even though the value of that non-primitive type is the same. For example, you have two objects which have a property A1, and they're both the same, but they're the different reference. And then this check will fail because, you know, different references, and pure component doesn't handle that. So yeah, it has been 23 minutes into the presentation, and I have yet to mention Redux. So I think now is the time. For those of you who have not used Redux, a very high-level overview would be Redux provides the store. We have the store exposes a dispatch function. When we dispatch something to the store updates. That's the most, I guess, that's the shortest way that I could describe it. This dispatching part is usually done by a user action, or it can be like from a network event or something. And then once the store is updated, it can notify all of its subscribers. So it's based on a subscriber pattern. And Redux, has anyone used Redux without React? Have you ever tried it? So yeah, not many, I guess this is a significant number, so congrats. But not many people know that Redux can actually be used without React. And for example, you can use it in Angular or Vue or your own framework, wherever. It just exposes a method to subscribe to changes, and then what you want to do with those changes, that's your own thing. So the connector, or rather the subscriber to Redux for React applications is, I think, always React Redux. I've never actually seen anyone use another library to connect React to Redux. And what React Redux does is it provides this connect function, which takes some mapper functions and then wraps your component in a higher order component, which injects props from the store into your component. So that mapping from the state, or rather selecting a part of the state and then injecting it as props into the component, is usually done by a function called map_state_to_props. And this function runs every time there is a store update. So you can imagine that it can be pretty, if you have lots of connected components, you can imagine it can be pretty expensive to actually dispatch an action, because all of these map_state_to_props are suddenly being run again. And this pure component here in quotes is because React Redux tries to actually optimize for this case, where you have, well, as you probably know, when you do an update in Redux, if a reducer has received an action which isn't relevant to it, it's supposed to return the same reference. And then if it has received an action which it actually needs to act upon, it needs to create a new reference. React Redux uses this to implement sort of a pure component-ish thing, which is when map_state_to_props is run, it does a shallow comparison for you between the old result of map_state_to_props and the new result of map_state_to_props. And if those two things are equal by reference, then it does not re-render your component. So that's why I talked about the references on the last slide, because you need to make sure that your selectors, or rather your functions which select a part of the state and then inject it into your component as a prop, you need to make sure that these functions always return the same reference for the same inputs from the store. And to achieve this, obviously some selectors can be simple, some can be more complex. It's usually a good pattern in Redux to actually keep some, let's say, raw data in the store, and then use selectors to actually transform it into something that your component uses. And this transformation can often create new references, which would cause your component to re-render each time, even though its inputs are the same and it might not need to. So to help with this, there is a technique called memoization. Has anyone used memoization for selectors or for anything else? Okay. So memoization, for those of you who have not used it, is when, like the simplest explanation would be when you have the same input results, you do not actually compute again what you have computed before. You just fetch the results. So it's like a caching mechanism. If you, for example, like the simplest possible example would be if you had a function which added two numbers and it received 1 and 1. Okay, I have not seen 1 and 1 before. I will calculate that result and return 2. But then if I receive 1 and 1 again, I'm skipping the calculation. I've seen these arguments before, and I can just skip to fetching that result from the cache and returning it. This is, in some cases, for example, when manipulating large arrays or doing some complicated stuff, this can lead to significant performance speedups. Okay, I'm going to jump to some examples now. These examples will be, some of them will be related to React, some of them related to Redux, some of them combined, and most of them will be actually regarding non-primitive types. Okay, first off, is anyone else annoyed when they are prototyping something, when they want to get something on the screen quick? They don't, if you use, like, if you render a list and then don't specify a key, React complains and it says, oh yeah, I need a key for this, you know. And then I'm like, okay, I don't have a key yet. I just want to see how it will look like and maybe adjust some CSS, or maybe I want to work on the, let's say, some event handler logic first. And then you put a key as an index, and then you put an index as a key, and then it's again complaining. Usually it's ESLint that says, oh yeah, don't do this, it's bad. And it's actually correct to complain. And in this buggy example, it's, let me just, here, it's correct to complain because if you have an index as a key and your list is not append only, so if your list is append only, then this will actually work, even though ESLint and I think maybe React, but yeah, it's probably ESLint will complain. So if you only append items to a list, then this is fine. But if your list has any other type of manipulation, for example, you remove something or things switch places, then this actually isn't even a performance issue, this is a bug, because your the React reconciler, that's the part which actually patches that's the part that does the let's say reconciling between the old and the new virtual DOM. It will not know what to do because your key is you might have swapped some places, but the key has not followed. The key has remained the same. So yeah, there's a much more in-depth explanation of this, but I've probably messed it up. Yeah, this, if you do this, it's okay only if it's an append-only list, but even then try to avoid it. Arrays, keys, like when you use a key, it should be predictable and it should be stable. Predictable and stable means that it will not change over time. So if you do something like this, and this is my example of an unstable key and a non-predictable key, this means that React will throw away your entire component and initialize a new one whenever this list is re-rendered. I often see something like this in legacy code. It was usually written by junior developers who had some logic in the, for example, will mount or did mount part of this component here, and then they didn't know how to handle an update, or they didn't really want to use component did update for some reason. So they just were like, oh, yeah, I'm not going to bother, just reinitialize. And yeah, it's okay sometimes if this list is not large, but if this list has many items, then throwing it all away and reinitializing it can be an expensive operation. A good thing, and the intended way this is meant, the intended way, or rather the recommended way to do this is to actually have some sort of stable ID from this item. And usually, at least in my application, this is an ID which comes from the backend, which was generated by the server. However, there are some cases where you do not have something like this. So for example, the server doesn't have any IDs, or this is something that you have generated on the front end and then you need to display. In such cases, it's I recommend, and in general it is recommended, that you generate a stable ID, and then you can generate it the first time and then reuse it every other time this list is, for whatever reason, manipulated. Okay. The second thing, and imagine if this was all in a render method. So as I said, references are very important when you use, for example, a should component update or a shallow equals or a pure component, because if you do a shallow equals with a non-primitive type, then you need to have the same reference. And if you have something like this or any of these, in the render method, each time your component is rendered, these are all new references. This is an anonymous reference. This here is an anonymous reference with some items spread inside it. Map creates a new reference. Filter creates a new reference. Slice creates a new reference. I don't know. There are others which I'm forgetting currently, which create a new reference. And this was, I guess I learned it this way, and this is intuitive to me. But for example, in Java, there's a sublist method, and it does not return a new reference. Actually, modifying this sublist will reflect on the original array. And that's not the case, for example, if you use slice in JavaScript. It will create a new reference, and then you can do whatever you want. So yeah, if you can help it, don't have these in the render method. Have these inside your either a level above, and then somehow memoize this, or in your selectors, which should all be memoized whenever you can also have this, because if you memoize something, for example, if you have a selector which memoizes by reference, in Redux, if this items thing, imagine if this came from Redux, if it has not been updated, you will get the same reference. And then, because the selector sees the same reference, if it's memoized, it doesn't need to recompute, it just returns the same reference back. And then you can, a component using this, if it's a pure component, it doesn't need to re-render. Okay, similar for objects. Again, anonymous reference with two spreads inside it. Also, object assign doesn't really create a new reference. It just assigns properties right to left. However, when you do something like this, this is actually a shallow copy of these two objects merged together. So something, I think these two are equal. And a shallow copy means that any nested object is not copied by value, it's copied by reference. So if you modify that nested object, it will reflect in the original object as well. Yeah, these things are also bad inside render. Try to use these inside the memoized selector or something that is memoized. Okay, I guess this would be the most common performance degrading mistake I can find or I encounter in my everyday work. And this is something that I do like myself a lot, because it's when these are reducers. So they, for those of you outside of Redux world, reducers are functions which receive the current state, they receive an action, this is destructured here, and then as it says here, action type check omitted for brutality. So if this action is not relevant to this reducer, then it will just return state. Otherwise, it will act upon this information from the action and return something new. And as you can see, this here, even though we are only modifying a single item, so we have an ID of an item we want to modify, and we have the new value for a property of that item. Even though we only want to modify a single item, we have actually created a copy right here for each item in this array. And then if we are rendering that list, and the components which render this are pure components, then they will all re-render because we have gotten new references instead of just saving a reference. So this is the intended approach, or rather the better approach. However, I really dislike it when my arrow function has a body. I don't know if anyone else has that, like, I don't know, mistake in their brain or something. But yeah, if I try to avoid arrow functions having a body, so I write this if I know that this array will be small. Otherwise, I try to stick to this. And this is something that I always tell my developers as well, to make sure that, you know, you are optimizing, but then like keep it on a healthy level. Don't over-optimize when there's no need to. This is the second most common thing I notice. So functions are non-primitive types. So if you write a function in line like this is on each render a new reference. And then if this thing was a pure component, it will re-render every time. A better way to do this is to actually have a class method, and then this reference here is the same reference on each render. Same principle as all the other stuff before. This is something that I guess needs careful thought when you actually implement. So if you have these components, and again, imagine that you have already tried to optimize these and made them pure components. If you have an item which takes one prop, whenever this item changes, this entire component will get a re-render, and we will not prevent it by virtue of being a pure component. A better way would be to actually spread the item, but then we cannot always do this because, for example, item might be this giant object with all sorts of irrelevant properties, and it can also be we can also have some naming clashes, for example, from a higher order component this does. So the best approach would be if the number of props is something manageable, I'd say around 3 or 4 max. If it's more, then just default to this and handle it in another way. But if you have this component taking like 3 or 4 things and then rendering based upon these, if you do this, I'd like to call this manual destructuring, or rather having exact props which this component needs very explicitly like this, then you can take advantage of pure component. It can do this update for you. It can do the shallow check for you, the reference check, and not re-render if there is no need. Okay, this tip is specific to React Redux. So in our application, we have these thunks. Has anyone used thunks? Okay, significant amount. So thunks are actions which are not objects. Usually in Redux, you dispatch objects. Thunks are not objects. Thunks are functions. You dispatch these functions, and then there's this middleware which injects dispatch, and then it also takes a second get state parameter. Anyway, it injects dispatch into that function, and then what this enables you to do is have asynchronicity in your actions, where you can, for example, make a network request or several, and then once that network request completes, you can dispatch relevant actions. And in my application, we have all of these fetch initial data. For each page, for example, it fetches what it needs in order, and there's a spinner before it is actually ready to show. And earlier, before we optimized it, we had these granular actions, and I love granular actions because it's, I think, the intended way to use Redux. So you only want to have these specific tiny actions, which then your reducer acts upon, and then this is also easily unit testable. So we have these tiny actions, and then they are all dispatched. And if you do it this way, you have 3 distinct store updates, which means all of your connected components have their map state to props run 3 times. And obviously, this sometimes is not an issue at all, but it can be. To avoid this, you can do it in 2 ways. I don't recommend this one. This is like creating a giga action, which contains all of these. And then you have, for example, if these 3 results from the network are related to 3 different parts of the state, completely irrelevant one to another, then you would have this one action being handled in 3 different reducers. I find that ugly, but yeah, it's, I guess, an acceptable solution. And this is what I would do. I think from version 7 of React Redux, there is a batch function which is exposed. And that batch function is actually just, let's say, it internally just calls React's unstable batch updates API, which you shouldn't use on your own. But these guys expose it, and then what you can do is have the best of both worlds. One distinct store update, but granular actions, which then do their own thing. Okay, and there are some things you can do to optimize which are not strictly React Redux dependent. They are more like architecturally oriented. For example, if you have a component which re-renders a lot, then you don't need to worry about that component's children if it doesn't have any children. I had this problem personally. I was wondering why my application was re-rendering a lot, and then it turns out there was some component which was wrapping my entire application and doing its own thing, and it didn't need to do that. So I just made it a sibling, and then it's still doing its own thing. Rest of the application doesn't care about it. And if this is a very significant problem, then you could take it a step further and if possible, completely isolate it. For example, this would be something like a micro front-end architecture. Has anyone ever used that or heard of that? Okay, small amount of hands. So yeah, if you decide to do something like this, if you can completely isolate it, then you basically have these 2 very distinct applications running on your one web page. This is not always doable, and I personally dislike it, so I cannot recommend it, but something to consider if possible. You can also escape React completely and call back when necessary. I did this once when I was doing some drag and drop functionality for a part of our application, and then I needed to animate the DOM node which was being dragged around by the mouse. And if you try to actually have this position of your component in React state, it's incredibly janky and slow because you're going through the entire React lifecycle, where you just want to update some inline styles for that component as you drag it around. And move events really fire a lot when you move the mouse. So what I did, and what proved to be very successful performance-wise, was escape React completely. Like, I got a reference to the DOM node that I was dragging. I did some pure JavaScript inline stuff to just modify its styles, and then as I was dragging along, there was this placeholder which needed to be placed by React in the DOM. So whenever that placeholder changed places, I could simply, I had a callback, and I could simply call back to React and say, okay, update now. And this meant that I'm not updating as I'm dragging the mouse, but rather as I am changing the position of that element. So yeah, you can escape React and then call it back when you need to actually make changes. And finally, there is the thing about not connecting components. Yeah, you should not be afraid to do it. Like, usually what I see juniors do is they would connect like a top level component and then just do everything there, have all the props, all the state from Redux there, and then just pass it along as props down the tree. Don't do that. You can connect lower. I don't actually have concrete advice. It depends on your actual use case. And yeah, this is my final slide before questions. When dealing with performance optimizations, always measure. Never try to rely on your feeling or how it looks. Always use tools. React Dev Tools can help you. Chrome Dev Tools can help you. Both of these basically deserve their own talk on how they are used to help with optimizing performance. If at the beginning of a project you know that you might have performance as an issue, you should consider using MobX. MobX also deserves its own talk, but in essence, it contains many of these optimizations it does these optimizations out of the box for you, so you don't need to worry about optimizing performance. You can develop your features, which is what we ultimately all need to do. And yeah, this one is personal. In a code review, I guess 1.5 years ago, rather a performance review, I got feedback like, yeah, we're really satisfied with your performance, you're doing great, everything is amazing, but sometimes your performant code is not really readable. And then it was a big question in my head, like, so what? I want it to be performant, but then as it turns out, companies are often very aware that they have a performance issue and they're fine with it. They don't want to optimize the application, they want to optimize developer time. So they are choosing to make the user pay with their time, and as they do not want to pay the developer to actually, try to understand this very performant code because it's less readable. So yeah, that is something you also need to consider. And that will be all.
Okay, we do have a few questions.
Okay, I'm sorry this took a little bit longer than I thought it would, but yeah.
No problem.
Okay, I'm not sorry.
It's the last presentation, so we have some time.
Okay.
Downsides of Redux to state management.
Downsides, it can be verbose. Whatever you want to do, you need to create an action and then dispatch that action and then handle that action in a reducer. And this whole ceremony is, when I first started working with Redux, it was it was tiring me. I just want to change this thing. Why do I need to go through this entire process of creating an action, dispatching an action, then handling that action? It's, I guess, one of the main things that is bad about Redux, and then I guess the part where you need to manually optimize performance. But other than that, Redux is great. It scales really well. On our team, we have around, I don't know, 30, 40 developers who have worked on our application, and they all could seamlessly integrate on the front-end part.
Is it good practice to combine Redux and RxJS?
Never did it, don't know.
When are you satisfied with performance?
I guess I'm satisfied when I don't notice performance issues, which is for me usually between 45 and 60 FPS. And like anything lower than 45, you can clearly see it with your eyes. Even anything lower than 60, but you don't bother if it's like between 45 and 60. So I'm satisfied if I don't see any performance issues.
And in your opinion, how could Redux improve in the future?
I guess that's a good question. Well, it doesn't actually solve any asynchronicity problems which we have. For example, if you want to fetch something from the server and then have it in your store, you need to resort to this middleware, or rather this middleware external libraries like thunks, like sagas, like whatever else there is. So I don't know how it could be solved, but I guess out of the box something about that could be done.
Okay, and what is a typical mistake a junior developer makes when trying to optimize the app?
I guess the most common mistake, not only for juniors but in general, and this is something that I personally do as well, is trying to optimize before performance is an issue. So always try to make sure that you are developing the feature first, and then if performance is an issue, optimize. Otherwise, if you are wasting time optimizing something that is not an issue and not working on the feature itself.
How to decide what to put on Redux versus React State?
Oh, yeah, great question. I don't have a definitive answer for it. I guess it is feeling based. So I try to put most business logic related stuff into Redux and stuff that would be used, for example, in different parts of the application. And then in local state, I would put something like whether a button is hovered, or I don't know, something specifically related to only that component, which will not be needed by any other component up the tree or to the side, or like a sibling.
What does provider exactly do in React Redux?
The provider actually takes care of subscribing to state changes. So as you probably know, the provider usually wraps your entire application, and you pass the store as its value. And then what it does, it subscribes to the store, and once the store updates, Connect actually wraps your component in a context consumer. That consumer, once the store updates, gets re-rendered.
Okay, MobX versus Redux?
Yeah, so not many people have raised their hands when I ask about MobX, so I don't know how in-depth about this I could be, but they are both very similar. Right now, Redux is, I guess, a lot more popular because it's, I believe, was created earlier, and it's also very easy to understand. Once you get the basic concepts, that's it. MobX is great for performance stuff, and Redux, if like performance is not an issue, you generally want to use Redux. Otherwise, consider MobX.
Have you ever used Redux Saga?
Yeah, I like sagas, except for this one little bit where you cannot actually, you know, everything in sagas needs to be done with actions. You cannot actually, for example, in your component, when you are using a saga, you cannot, like right there where you have called the saga, or rather dispatched an action which would be called, which will then be handled by the saga. And at that point, you cannot handle the result. With thunks, you can do it. Thunks can return promises, and then you can, for example, then that promise, and you have the result of that call right there. But with sagas, you actually need to go through this entire thing with actions. So that would be the main, I guess, bad thing. The good thing about sagas would be, I don't know, you can cancel requests, and they allow for much more granular control of your actions, of your flow.
Did you or would you ever make a hash of a stable property of a list item and use it as its key?
A hash of a stable property in a list item. Well, I have never actually had to do this, but yeah, I guess that could be done. Has anyone here used symbols, like ES6 symbols? Okay, so if you need like a stable reference, a unique reference, and you don't need to stringify it, and you don't need to, you know, do anything with it except need it to be unique, you can use symbols for that. So you can hash a property which you know to be stable, or for example, you can also use a symbol.
And have you tried the Redux starter kit?
No.
How to measure calculation time in should-render method and compare it to render time?
How to measure, sorry?
Calculation time in should-render method and compare it to render time.
Well, this boils down to the dev tools, which I like went over really quick. So in Chrome DevTools, you can basically measure the execution time of any part of your code, and then just simply measure that part, measure the other part, and compare them. And try to make the comparison fair, as in do the exact same things when you compare, and also when you do it, for example, don't encode video in the background because that's wasting CPU time. You might not get a realistic result.
Okay, and the last question for today. Have you tried and would you recommend why did you update tool?
I believe that that's either a library or like a snippet. I'm not sure. I've heard about it. I personally, when I'm unsure why a component has been re-rendered, there is a snippet on Stack Overflow which I have bookmarked, which is a component did update, and then basically it goes through each property of state, each property of props, and then does a shallow comparison. And if they are not equal, it logs them out to the console. I've used the snippet a lot of times. I haven't used it. I believe that it's the same thing, or the principle is the same, but yeah, I use a snippet for that.
Okay, thank you.
Thank you.